In 1938, a chemist named Roy Plunkett opened a gas cylinder at DuPont. Nothing came out, the gas was gone. In its place was a white, waxy lump that would not react with anything. Not acid, not base, not fire, not time. They had just stumbled into the most chemically stubborn material anyone had ever seen. And what did we do with the most inert substance on the planet? We coated frying pans with it. Humanity is adorable. The substance is called polytetrafluoroethylene, PTFE. You know it as Teflon, and the reason nothing sticks to it is one of the simplest stories in chemistry. Carbon and fluorine form a bond. That bond is the strongest single bond in all of organic chemistry. For context, that is stronger than most marriages and all of your New Year's resolutions. PTFE is just a long chain of carbon atoms, each one holding hands with two fluorine atoms, and those fluorine atoms do not let go, they do not react, they do not share, they do not even want to be touched. Picture the most antisocial molecule you have ever met. That is PTFE. Water slides off it, oil slides off it, eggs slide off it. It has the lowest coefficient of friction of any known solid, which means it is measurably the slipperiest thing that exists, and it is everywhere, not just your kitchen. PTFE lines the joints of the space shuttle, it insulates wiring in fighter jets, it coats the inside of chemical storage tanks because even concentrated sulfuric acid looks at PTFE and goes, nah, I'm good. Your nonstick pan is the boring application. The real story is that PTFE is one of the most useful polymers ever made. It works in surgery, it works in semiconductors, it works anywhere you need a surface that simply refuses to participate, and here's where the story gets uncomfortable because the molecule itself is fine. PTFE sits there inert, minding its own business. The problem was never the polymer, the problem was how we made it. To manufacture PTFE at scale, DuPont used a processing aid called PFOA, perfluoroctanoic acid, a smaller fluorinated molecule that helped the polymer form evenly in water. PFOA did its job, then it leaked into the groundwater. In Parkersburg, West Virginia, the DuPont Washington Works plant had been making Teflon for decades. PFOA seeped into the local water supply. DuPont's own internal studies showed health risks starting in the 80s. They did not tell the public. They never told the EPA. They kept manufacturing. By the time attorney Rob Bilott forced the documents into daylight, PFOA was in the blood of nearly every person tested in the Mid-Ohio Valley. The class action settlement funded a massive health study. The study linked PFOA to kidney cancer, testicular cancer, thyroid disease, and more. The carbon-fluorine bond that makes PTFE so useful, PFOA has it too. Same bond, same stubbornness, except PFOA is small enough to dissolve in water, travel through soil, and settle into your bloodstream. The virtue of the product became the curse of the process. DuPont eventually phased out PFOA. They replaced it with Gen-X, which is also a fluorinated compound, which also showed up in drinking water near the same plants. The punchline writes itself. Here's what gets me about Teflon. The polymer is genuinely brilliant. One of the great accidental discoveries in chemistry, a material so inert it borders on philosophical, and the story should end there, but it does not end there because the system that manufactured it treated the community around the factory like the cost of doing business. The molecule did not fail, the oversight did. That is Catalyst, one substance at a time. Subscribe if you want more. Topping a polymer that repels everything, including corporate accountability, will take some serious chemistry.